see who else is here. Okay, Hitesh, Prabhu, thank you. It's always good to send a message when you connect back because it will gain. When you're done with the break and just come and join it. Sunil, good to see here. Okay. All right, so let's start from where we left. So we're talking about one-to-one relationship, nurse ID and nurse in charge. We just, foreign key is good in the relation of the optional side, matching the primary key on the mandatory side. This is the mandatory side. And this one is the, this one is the optional side. There might be a care center. And if there is a care center, again, so nurse in charge, there has to be one nurse in charge over there. Now let's move forward. Mapping associative entities. Identifier not assigned. Default primary key for the association relation composed of the primary keys of two entities, MN. Identifier assigned, it is natural and feminine. So again, it will have two situations, associative entities. When identifier is not assigned and identifier is assigned. It is natural and feminine with the end users. And default identifier may not be unique. Now let's talk about this one. Mapping an associative entity. So you see that we have got order line, and product. So again, you can look at that one. The order line has, if we talk about that, order line has to have one order, and order line is an optional one. Product might exist without that one. So if you look at that one, associative entity composite. So we have order over here, order with order date. Note that product line ID is included here because it's a foreign key into the product line entity, not because it would normally be included as an attribute of the product. So look at that. It is basically what order ID, and then order line has order ID and product ID, and with the ordered quantity, and then product. So product is there. So if you see composite primary key form for the two foreign keys, so because this order line has two foreign keys, order ID from order then and product ID from the product. So we combine them and we just say that it has a composite associative key that is basically coming from two different resources, and those two different resources we have got, used over here, right? So that is basically just allocating the associative entity. Now mapping of associative entity with an identifier. If there is an identifier, what will happen? If you look at that one, look at that. So customer ID, when we are making a relation, customer ID, customer name. And if you look at that one, primary key differs from the foreign keys. So over here, if you look at that, customer ID is coming from here and vendor ID is coming from here, and it has its own shipment ID as well. So what we are doing is that, again, it will have primary key differs from the foreign keys. So primary key is basically different from the foreign keys. Over here, if you look at that, this shipment will have shipment ID, customer ID, vendor ID. Both of them will be coming from that, and they have its identifier, with an identifier. It has an identifier by itself. If you look at over here, we had composite primary key over here, but if you look at that over here, we always get a single ID key, but these are primary, these are the two foreign keys that are coming from them. Right, transforming EER diagrams into relationships, continuing mapping unary relationships. Now, relationships can be of different kinds, different types. Unary is one of them. So when we say unary relationship, we are talking about, having involving one entity type only. So one to many, recursive foreign key in the same relation, many to many, two relations, one for the entity type, one for the associative. Now look at that. If we have an employee manages multiple employees. You see that? It has one into many relationship, but it's a recursive one, cyclic one. Employee entity with a unary relation. It's a unary relationship. Employee is related to employee. So just remember that again, this unary word is used when there is only one entity or one thing is being involved. So here what we are saying that one employee can manage multiple employees. Now, interesting is that again, if you look at that one, that one employee can have optional multiple many employees and it manages them. Now, how to map that on the relationship, like on the table? We do that employee ID and employee name and employee date of birth. And since it's a recursive one, so we'll give it a manager ID as well. I guess when it is managing, it would be a manager ID. And when it is not managing someone, of course, a simple employee, this manager ID might go none. Make sense, everyone? One into N relationship. So if it is manager, like, if an employee is a manager as well, so, the new employee who's it is managing to, they will have that typical manager ID into their relationship. Right? So that is for that one. Now mapping a unary M into N, like M to hello? Speeches. Sorry. Someone wants to say something? Okay. So many to many, many to many relationships. So look at that. So one item, like, item number, description, unit cost. It can contain multiple items. So item can contain multiple items, and then there is a quantity. Now look at that over here. So how do we relationship item and component relationships? We'll just create item number, description, unit cost, and then we'll create a component. So that will have item number, component number, and quantity. And the component number, if you look at that, component number will be coming up from that item number. So this item number component is unique for that particular one, but the component means from which component it connects to. It will come from the item number. And that's a quite interesting situation where we have many to many relationships. Now transferring a diagram relationship, mapping ternary and n-ary relationship. When we say ternary, there are three entities being involved. And when we say n-ary means multiple, any number of relationships. One relation for each entity and one for the associative entity. Associative entity has foreign keys to each entity in the relationship. So where we have like associative entities that have foreign keys for each entity in the relationship, right? So just keep in mind that we have that one. So now let's come back and talk about this one. So when is a ternary relationship? A physician, patient treatment, patient ID, and treatment. So again, this is physician and patient. And when the treatment is done, treatment date, treatment time, results over here. And over here, treatment code and description. So these are ternary relationship. The physician has ternary relationship with patient and treatment, and this has with the relation with the treatments. Now look at that, how to map that one. Patient ID and patient name, physician ID, physician name, treatment code and description. Now look at that. Now here patient ID is coming from patient, physician ID comes from physician, treatment code coming from treatment, treatment date, treatment time, and treatment results. This is the treatment in between. Remember that the primary key must be unique. Primary key has to be unique. This is why treatment date and time are included in the composite primary key. So treatment date and time will be included in the composite primary key. I guess getting that one. This will be. So you see that they have been marked underline. So treatment date and treatment time, they are also added over here because again, patient ID it can be multiple. Physician ID can be multiple. Treatment code can be multiple, but treatment date and treatment time will make it different. Make sense, everyone? It is just like, in the aeroplane one that you have got same plane ID or the plane that is going on, the flight code of that particular one. But if you combine flight code with the date, then it will make it unique with the other one. Are you guys getting that one? So flight date plus flight ID will make it separate. So they're also thereby you will be just trying to make a relation. So remember this example over here I've given on this slide number 36 that flight date and flight can be combined together into one. Into relationship, mapping supertype subtype relationship. Remember subtype supertype, those who have looked at the recording of the last week, we have supertype and subtype relationships that appear. So let's talk about that one. One relation for supertype and one each for subtype. Supertype attributes including identifier and subtype discriminator go into server type relationship, and subtype attributes go into each subtype primary key. of supertype relationship. One-to-one relationship established between supertype and each subtype with supertype as primary table. Let's see that example. Look at that. Now, those who had looked at the recording last week, do you remember what this D represents? What this D represents? Those who had a chance to look at the last week recording, what this D represents? This is a question. Anyone who had a chance to look at, like, I'm just asking what this D typically means. Like D stands for what? Anyone remembers? Who had a look at last week's recording? D for what? No one is there to answer. Okay, it was disjoint constraint, if you remember. And if you can go and look at that one. Anyhow, so employee type, so super type and subtype, employee type. This is hourly, this is salaried, or this is consultant. So employee can be hourly employee, or it can be salaried person, like, monthly employee, or it can be consultant with a contract or something. So what it is having, employee type is equal to just representing H, S, and C. That was making them separate, super type, subtype relationship. And if I come here, so you know how would we do that? We'll just do that. Employee has this complete table relation, and then hourly employee, consultant has this one, and these are implemented in one-to-one relationships. So every employee, one employee can be hourly, or it can be salaried, or it can be consultant. So that's why it is one-to-one relationship, right? So that's because that was disjoint relationship over here. And needless to ask what these two lines means. I will not ask that. You will have to look at the last week's recording for these two lines. What does two line represents? What single line represents? There is a typical meaning to that. Anyhow, so here comes something, as I told you, that something that we have discussed, like again, that was discussed last week in our last, but I'll just give it a little bit more time here, because this is quite interesting and important topic. And again, it's good that it has been repeated for this one. Normalization, primary tool to validate and improve a logical design so that it satisfies certain constraints that avoid unnecessary duplication of data. The process of this decomposing relation with anomalies to produce a smaller, well-structured relation. Data normalization is very important. And again, according to this slide, it says process of decomposing relations with anomalies to produce smaller, well-structured relations. So normalization can have many definitions. One of the definition is written over here. We need to normalize the data. And normalized data means we remove anomalies. We remove anomalies. And again, those who had a chance to look at the last week lecture, I've defined that one. So again, those who are looking at this recording and they had already that practically that class we got. So unnecessary duplication removal and producing well-structured relations. That is called normalization. So well-structured relation, what are the well-structured relation? A relation that contains minimal data redundancy and allows users to insert, delete, and update rows without causing inconsistencies. Now, this is something that you need to remember. On this 41 slide that we are talking about, on this 41, we have just talked about a relation that contains minimal data redundancy and allows users to insert, delete, and update rows without causing data inconsistencies. So again, to remove inconsistencies, and we have talked about that previously as well. To remove inconsistencies, number one, and as they have mentioned, remove anomalies. Remove anomalies. So remember, that is the purpose of a well-structured relation will be one that has these anomalies solved. Now, goal is to avoid anomalies. And what can be anomalies? Insertion, deletion, and modification. And again, as I said, it's a repetition. We have talked about adding new rows forces user to create duplicate data. Insertion anomaly. Deletion, deleting rows may cause loss of data that would be needed for other future rows. So again, you are removing something and you are not able to just run that one. We talked about some of the deletion anomaly today as well. Can anyone tell me where did we talk about a little about deletion anomaly in our one of the part today? Deletion anomaly, and I gave you an example that if you want to remove this, that will happen, and that might be a problem. Does anyone remember that one? And that is something that we have discussed today, by the way. So if you want, I can just quickly show that to you, just to remind you. Here, if you remember, I told you, remember that where was that? Yes, the constraints, and we talked about this referential integrity. If you remember, delete rules. You remember, restrict, do not allow delete of parent side if the word. So that same thing, over here, the anomalies are produced, and we want to remove, or we want to just save ourselves from all these anomalies, so that we can just have well-structured them. So insertion anomaly, deletion anomaly, and modification anomaly. So I just given this 41, relationship with that number 10 delete rules. So 41 and 10, they were related. So you talked about their relationship, right? So basically, this one is, let me just talk about. So well-structured relation will be general rule of thumb. A table should not pertain to more than one entity type. This is very important. And to give it a very simple wording, a table should contain or should represent only one value. Value means one thing, one entity. Should only represent one entity. Right? One entity. Okay, wonderful. Now next, this is very interesting. Now this is example to normalize, and we'll just see that what are the anomalies and how to do the normalization form. And again, this is another example. We have seen one example last week as well. Question. So first of all, there is a table being given over here. Question, is this a relation? Answer is yes. Unique rows and no multi-valued attributes. Do you look at that? Unique rows, 100 Margaret Simpson marketing, 48,000 SPSS. 100 Margaret Simpson marketing, but 48,000 after surveys, and date is changed. So all, like here, if you see in this 190 Lorenzo, whatever finance, and there is no course title over here. So are these tables? Yes, because rows are unique from each other. No two rows are exactly the same. That's why that is table. Right? And no multi-valued attributes, no multi-valued values as well. Question, what is the primary key over here? You see that, what is the primary key? 100 cannot be primary key because 100 is repeated. 140 cannot be primary key. Maybe we have 140 multiple records if an employee has taken multiple courses. So answer will be composite employee ID and course title. Employee ID and course title. If I combine them, that will make them separately. Make sense, everyone? So if someone asks you and showing this type of table, and if there are no repetitions, is this a relation? So you will answer yes if the rows are, first of all, they are unique. And secondly, they are actually, they are at, like not multi-value. There is no row, no column which has no field which has multiple. So if I could write SPS colon text ACC, or for example, text SPS colon surveys, you would say that this is not a relation, because for a relation, it is important that it should have those features. So that might be a potential question in the exam, recognizing something as a table, and then finding out what should be the uh, the, the primary key in that situation. Because here, employee ID and course title will make, I cannot make employee ID or salary, employee ID department name, because they are also repeating. So, the course is something that is not repeated. Course is individual. So I will say, okay, take the employee ID, go to the course ID, combine them, and that will make up a unique number, right? Okay, anomalies in this table. Look at that. What are anomalies? Can't enter a new employee without having the employee take a class. Now look at that. If I want to insert a new employee over here, that employee has to have, for example, one course being taken. One course being taken. Because course title, because I'm saying that, maybe that, course title and employee ID are typically, these are combined, and they're making over here. So I cannot insert that one. Delete. If you remove employee 140, we lose information about existence of tax act class. If you remove 140, there will be no record left for taxation and accounting. So taxation accounting will be gone if I just remove 140. The delete anomaly. Modification, giving a salary increase to employee 100 forces us to update multiple records. If we say that salary is increased for this employee and from 48,000 to 55,000, for example, now I'll have to change this row, then this row, then wherever the rows are, I'll have to change this Margaret Simpson's salary. In that regard, why? Because I have changed the salary for one. So it means that I'll have to just do that. Now, why do these anomalies exist? Because there are two themes, entity types in this one relationship. This results in data duplication in an unnecessary dependency. There are two themes, entity types in this. So you remember we have talked about rule of thumb. Remember rule of thumb that a table should only contain one entity. But here we have two types of entities. So why there is there that it has two duplicate entities. Now let's see that. Functional dependency key. Functional dependency, the value of one attribute, the determines the value of another attribute. Each non-key field is functionally dependent on every candidate key. Now this is very interesting. Look at that. If I come here, this is not a relation. Now this is not a relation. Why? Because you see 1006 you have, and you look at that product ID. There are three product IDs for that particular one. And there are three product description. There are these. So this is not a relation, remember. But if I come over here, this is a relation, but not well. So now we have separated out 1006 to font, and these are separated out. This is a relation. Maybe the keys, the rows have become unique, but the problem is it's not a well-structured one. Why? Because they're repeating values, the same values being repeated multiple times. That's not good. So what to do? Anomalies in this table. Insertion: if new product is ordered for order 1007 for existing customer data must be re-entered, causing duplication. So if someone has 1007, there's what is that? For 1007, we are entering any record. We'll have to enter all the record of that one, the furniture gallery name, the boulder, whatever, and the name or the address and everything. We have to just repeat that one. Insertion. If we delete dining table from order 1006, so how would add picture in the table? What does that mean? Add picture to the table. Picture to the table. I'm not getting your point. Mean if any picture insert in the table. Oh, so picture insertion is done in multiple ways. There's something called a blob, or we just, sometimes we put some tables might contain directly the picture, but some of the pictures there, we just reference them, their names over there. But here the deletion anomaly is that if we delete dining table from order 1006, we lose information concerning this type items and finish. So if dining table is removed from here, for example, the product over here, where is the dining table? So if we remove that dining table from here, where's the dining? This one. So if the dining table is removed, its values and if you see that we lose information concerning this item's finish and price, because then there will be no other record. Update: changing the price of product ID 4 requires update in several records. So if ID 4, if you want to change the value furniture, because entertainment center, natural maple, if you want to just change the price, you'll have to change multiple fields. Now, why do these anomalies exist? Because there are multiple themes, entity types in one relation. This results in duplication and unnecessary dependency. Again, the same thing, that it has dependency. Second normal form. This is important. One NF plus every non-key attribute is fully functional dependent on the entire primary key. Now we'll see the example. Order. Every non-key attribute must be defined by the entire key, not only part of the key. No partial function dependencies. Now this is very interesting. Look at that. So here, if you look at that, order ID is dependent on order date, customer ID, customer name, and date. Order ID dependent on order date. Customer ID dependent on customer name. Product ID, product description, product finish, unit price, order ID, product ID, and contract. Therefore, not in second normal form, because some of them, they have transitive dependencies and there are partial dependencies over here and partial dependencies. How to solve that? How to make that in the 2NF? Look at that. Partial dependencies are removed, but there are still transitive dependencies. So partial dependencies are removed: order ID, product ID, ordered quantity. Product ID, product description, product finish, unit price, product. Order ID, order date, customer, and this is customer order. This is in second NF form. There are some transitive dependencies: customer ID, customer name, customer address, that would be repeated, but it is into the second form, partial dependencies are removed, but they are still transitive dependency. So now let's do that what? So now you will call it, this is in 2NF. This is the 2NF, second normal form. Now third normal form, 2NF plus no transitive dependency. Now even if you remove this transitive dependencies, this is called 3NF. Look at that. 2NF plus no dependency. Functional dependency and non-primary key attributes. Note, this is called transitive because the primary key is a determinant for another attribute, which in turn is a determinant of the third. Solution, non-key determinant with transitive dependency go into new table, non-key determinant becomes primary key. Now look at that. We create a new table. We create a new table for customer and just leave customer ID over here. Are you guys getting that one? Now all customers will reside over here and their ID will go into order ID. So if you come over here, you see that these three were the transitive ID over here. So what we did customer ID separately and we took out from the order, these just left the customer ID and we produce another table. Make sure you understand that one. So this is transitive dependency. We have taken out the transitive because otherwise in this order, whenever order will come, we'll have to enter customer ID, customer name, customer address every now and then, which is useless, which is not required, which is not desired. Right? So now third normal form, second NF plus no transitive dependency, functional dependencies on non-primary key. Note this is called transitive because the primary key is, so we have just talked about that one. We have just seen that one. And now if you look at that, merging relations. View integration, combining entities from multiple ER models into common relations. Issues to watch out for merging entities for different ER models. Synonyms, two or more attributes with different names but same meaning. Sometimes, you will come across this situation that some attributes, they will look like different, but they are in essence, in meaning wise essence, they are same. Homonyms. So attributes with the same name but different meanings. They're called homonyms. Transitive dependencies, even if relations are in 3NF prior to merging, they may not be after merging. Supertype subtype relations may be hidden prior to merging. Look at that. So we introduced primary keys. Primary keys that are unique in a whole database, not just within a single relation. So they are enterprise keys, correspond with the concept of an object in object-oriented system. Just remember that primary key that is unique for whole database, they are called enterprise keys. And they are typically referred to the concept of an object ID in object-oriented system. So look at that over here, enterprise key, object ID, employee, and customer. So they have, this QID, OID, in fact, and that OID is basically being mentioned in everywhere and it is common for all them. It is called enterprise key. Right? That is called enterprise key. Makes sense? Relationship with enterprise key and sample data with enterprise key. Sample data, employee, customer, employee. So they have this OID and this OID is referred to and in that particular one. And as we have said that enterprise keys are global and enterprise keys are common throughout the database. They are throughout the database and they're basically common for that particular one. So this is, a bit of repetition of NF, 3NF. Those who are looking at the recording later on, please see that we have just repeated that one. So I'll share the slides with you on that one. But the second part of our lecture today, where we will just start writing some of the code, it will come from our this week 4. And I'll again let's first of all let's do something. I save this one and I upload it for you guys here. And the code will also come here. We'll just right now just taking lecture 4. So it's there. And the next one that is we are discussing is joins, which is there already. Can you find that joins on your folder? And again, it's a previous one. It's a very important topic, and this is something that we'll talk about now to have our some of the joinings of the table. SQL joins. What does it mean to join two tables? In any database, we typically have different tables to represent different types of things. abstract objects or concepts, or physical entities such as people or car parts or etc. In a well-designed database, rows in every table are uniquely identified by a value called primary key PK. Example, student number, invoice number, course number. In a relational model database, we represent the relationships through the existence of a primary key values in other tables. When these values exist, they are termed as foreign key. We have talked about that. PK and FK, the primary key and foreign key. So representing relationship in a well-designed relational database, all tables have primary keys, which are unique identifiers. A table that has a primary key involved in a relationship is sometimes called a master or parent table. The master or parent. A table that contains a reference to primary key is called table, is sometimes called detail or child table, like this, right? Zero or more rows in the detail table can refer to the same row in the master table. So now again, that's same, that if there are multiple rows and multiple, it would be just mentioned over here. So inner joins. This is very interesting, inner joins. So we have, for example, this number CDEV0, whatever, and it's the course and credits and the course number in the session code.
Wow.
Sorry. What is that? Okay. So it would just refer to what? These course numbers are basically being mentioned over here. Parent table with the primary key and child table with the foreign key. Foreign key comes over here with session code over here there. Now what will we do if we join them, like, if with the query, we'll see that CD V1020 co-op prep and F08. So we have just, we can join these tables. This is called inner joins. Course and course offering tables. So we can do the inner joins over here. Make sense? We'll just do the code over here. When you query the database, you often need to join the data from more than one table. You need to relate information from one table to another, either looking for matching values, typically matching primary and foreign key values, looking for absence of any matches, and you need more detailed information about an instance of an object, such as its name, not merely its primary key. So again, we'll see that the examples. For example, select course number, course name, course dot name, specify table of dot column, mandatory if there is an ambiguity, session code, capacity enrollment from course offering, course where course dot number is equal to course dot offering dot course number. This is the join. Join can, in this case, retrieve rows where the values in the course number columns match. Does that make sense to you? Just let me give you another example. I'll just give you some examples. So partial result of a join query. It will just go to the one table and the second table and will bring out all the columns over here. Right? So in the same way, inner joins, query designer with explicit join syntax. In the query, we can just find out the inner joins. How does it represents inner join, right? And we'll just see that. Qualifying column names. So if the same column name appears in more than one table in a join, it is ambiguous. Column name must be qualified in order to resolve the ambiguity. So table should be mentioned with the column name, and that is very much important. In our in our examples, that you need to mention the table over here. Make sense, everyone? So what we need to do is we need to just mention that how we can just basically combine multiple tables, and we can extract out the data from that particular one, and we can just use them for particularly that one. Make sense, everyone? So now let's talk about some of the examples over here, and let's see that what we will be just doing. So let's open up our SSMS, SQL Server Management Studio. Can you guys all open your SQL Server Management Studio? Okay, just connect that one. Hopefully it is connected. Okay, let's see if it is connected. And my this one will always take some time. I hope this is good for you. Oh, you see that my database will always create a problem. I'll just restart that one because I hope that's disconnected, but let's see that. Okay, it's there. Let's see if this time. Just bring up something here. Okay, so let's see that I have a file here. Okay, so let's rather. Yes, let's use the SIS. Do you guys have SIS table? Everyone has SIS table over here? Please let me know. Do you guys have SIS table with you guys? Can you let me know? SIS. We installed that in the beginning, right? Remember everyone? So we have installed that in the beginning. And let's do that one. So let's have a new query over here. And I'll keep that on the side, for example. So now see here. Let's first of all, we should have this SIS database because we created that one. I'm just going into that. And I have this SIS database over here. So now you know that there can be multiple ways of using that. I can say use SIS. First of all, if I execute that, look at that. This SIS will be changed over here. And that is what I required that one. Use SIS. Right. So SIS has many tables and you see, let me just show you the tables over here. What tables does SIS have? So one of the table is course of course and course offering. Let's see what is inside them. Let's first of all see that. Select asterisk from, let's say course first of all. If I run that, so I have in the course, I have the course number over here, hours, credits, introduction to course, the French name, whatever, the courses are over here, and the course offerings. Select asterisk from course offering. I'll use these two tables, right? So please do with me and just does with me. So this is course offering with a session code, the course number, right? If I run both of these statements together. So look at that. So we have got like, the number, the course number, and you see that the course number is basically appearing over here as well. If you look at that, these are the course number and everything is over here. And these are the two tables. So now we'll just try to just do some of the joinings over here. And we will just, try to just bring that one. So let's write first query about number one query. Right. So let's write number one query. And the query is again, what are available courses? What are available courses that we have, right? So we are writing for that one, what are available courses. So let's say, so I'll say select, and now again, course number, right? The course number is over here. If you look at that course number, which is being over here as a number maybe. So course number, and then comma, course dot name. Now see here, I'm going into that typical table course, and then from there, I'm just finding course dot name. Session code. Again, session code from the second table. Look at that. Capacity, right? And enrollment. Enrollment, right? So now enrollment from, so course offering. So you know we have got both of the courses, like both the tables from the course. Now what is that? Where? Now here comes the join. Course dot number equal to course offering dot course number. Now see here, these are the two different names over there. So look at that. We are saying that course dot number. This is the course table, right? So course table has a number field. So I'm saying course, select the course number, which is typically this field, course dot name. The name will come from the course table. So course table has the name over here. So bring that name. Session code. Session code is where? Session code is basically typically in our, in our second table, that is course offering. So bring that over here. The capacity. Capacity is here again in the second table. Then we have enrollment. How many people are enrolled over here? Bring all these values from course offerings and courses. So again, we are now mentioning two tables. So from two tables, bring them where course dot number. So look at that, course dot number. Now this course has this number, and shouldn't I write it small because that is in small, right? Small n. So course dot number equal to course offering dot course number. Here it is called course dot number. Course dot number. So now let's see that if you run that one. Look at that. Course number, it has been brought up. Course dot name. This is the name of the course, for example, over here. Session code over here. Capacity and enrollment. All these values are here from course offering course from both. It is joining the data from two tables. It is joining the data from two tables. Make sense, everyone? So this is basically, what are the available courses? It will just tell us CDEF 1020, which is session code 508, 30 capacity, enrollment 14. COP and preparation FO9 30 session code. So these are all mentioned, and it is just telling us that how many courses are there. And it says that 140 rows are there. Now we can do another this same thing by using aliases. And you remember aliases are what? Changing the names. So let's say select CO dot course number, C dot name. You will be saying what is this C, and we'll just talk about that. CO dot session code, CO dot capacity, and CO dot enrollment. From, now look at that, course offering. Now here I would alias them. Remember, I would alias them. So the table aliasing. So we are renaming them. So I'm saying course offering as CO. Make sense, everyone? And course as C. As C. Right? So enrollment, maybe spelling is correct, not correct. Enrollment should be double L. Right? Where C dot number equals to CO dot course number. what is the benefit of that? Can anyone tell me what is the benefit of aliasing them? The same output, it should be same output. But what is the benefit of aliasing that? Anyone? What is the visual benefit that we get of renaming or aliasing?
We could know from which table it is.
Yes, so now it has become easier for us. So you see that aliasing CO and C. So it tells me that exactly that what typically which table I am just talking about, and from which table I'm just referring to. So now it will just find out the course number, like C dot number from the course class. For the course table, it will take the number. It will match with the course number. Whatever will be matched, only those records will come out. And you remember, if I just go in the source, like course, we have got these multiple records, which are the French name, hours, credits, and everything. But here, when I'm just doing that, I'll say, just look at that. Let's run these two commands together, course and if no, I'm not able to select them. Now, if I run that one, so I'm just getting this join over here. Okay, now let's make a little bit more complex join. That will be interesting. Number three, more complex join. More complex joins. Now we want to see that how we can just make much more complex and more like data from that one. So let's say select course offering CO and like I'll just give that from select co.course number, c.name, co.session code, p.name as program. I'm just giving another aliasing over here, and co.capacity, and co.enrollment from course offering. Again, this is a table, so I would just call it alias co. And course C. Now here we have third table as well. Program course PC, and the fourth table program. We'll use the PC as well, and we have used the PC as well. We'll just use that one. So PC and program as P. Where C dot number. Now look at that, the join. C dot number is equal to CO dot course number. And do you guys remember and? Yes, easier to read and write. You're right. So and C dot number equal to PC dot course number. And combining multiple, PC dot program code equal to P dot code, and order by CO dot course number. Right, let's run that one. So it is now involving more than two tables. There are four tables, and we are combining records from them. So you see that internal join will bring what? It is bringing up the program over here. And as a program, its heading is program because I have alias that. I have just given that ID over there on the top. So it just brings up that one. And let's see. So it just typically does what? It takes out, it has the end position. So if C dot number is equal to course dot number in the courses, just check that with the course offering. It should be equal, and course number should be equal to PC dot course number. PC is program. We have just seen that. What is this PC? PC is the program code. So program code, and then PC dot program code is equal to P dot code, and program code also should be matched over there, order by CO dot course name and course number. And it is just ordering this by the course number, and the course number will be C dev, and it starts with this one. And now we have got 378 rows, which are bringing up the different values over here. Now here comes some interesting joins. The one of them is called cross joins. So now see that, select P dot last name, P dot first name, E dot business phone from person P and employee. Again, aliases. So now this is very simple cross join. We are saying that, we are just not making, equality. We are just saying that this is a cross join. P dot last name, P dot first name, E dot business phone from person. So now let's see that. So it just brings the last name, the first name, and the business phone from that, from, person employee. And this is basically, that will be matching over there, because if you look at that one, let me just show you. It has 6,000 rows basically. And I'm just worried that why it is showing the same phone number. I should show the different phone numbers. I'll just check that one. Showing the same phone number. That's interesting. Let's come back here and let's check that from what is then employee. Let's run that employee. And the phone number is same. You see that phone number is same for all employees somehow. Then yeah, that's why it is showing the same number anyway. So that's not a problem. I'll just cut that from here and I'll put that over here. So these are handy statements because they just keep on telling us that what we are doing. Okay. Now it is the implicit syntax that is directly just bringing that one. Now, if I want to write this one and in the explicit syntax, look at that. Explicitly mentioning that. Explicit syntax. Look at that. Select person dot last name. And again, we are directly using the table. Person dot first name and employee. Again, not using the the aliasing. Business phone from person cross join. This was cross join employee. Now we can just write down the word cross join employee. So now both of them have been coming up over here. Now I can just go there and again it just shows that cross joining and it just brings up the last name and first name from there. This is explicit syntax. Now another one. Let's move on. Look more. Number 6. Number 6 is self joins. So what is that? What are the IDs and phone extensions of all employees? What are the IDs and phone numbers of all employees and their immediate managers? And their immediate managers. Now look at that. We are doing self joins in the same self-join in the same table. We are joining in the same table. Now look at that. This is very interesting. Select E dot number, E dot extension, M dot number, M dot extension manager, right? From employee E and employee M. So see that we are using the same table, but aliasing with different ways. Where E reports to E dot reports to equal to M dot number. Do you see that? This is another very interesting self join because this is the same table. And you remember we talked about one. This is a unary type of relationship over here in this problem number 6. We are talking about unary relationship. So we are saying that one employee making mentioning or using managing the other employees. So what we do is that to do the self join, We will just combine them. E dot number, E dot extension, M dot number, M dot extension, employee, employment. So you see that same table being used with two things. And this is basically, again, this is one way of using this equal to sign. And the explicit syntax for this one. Explicit syntax. Now, explicit syntax means we use that typically the join keywords. Now, how to do that? Select E dot number, E dot, sorry, E dot extension, M dot number, M dot extension from employee. So this is just, we need to add the number. Employee, inner join, employee. So the same one, employee M. Now, notice that so whenever we are representing an inner join in this way, we'll have to tell which fields we are just talking about. So we'll use a keyword called on E dot reports to equal to M dot number. You know what I mean? Actually, we cannot just leave that over here because on which things you want to join them. So for example, if I take it away, if I cut this and if I just put that one, and if I just say run that, look at that statement line is syntax is because this is still remaining. So if I just put that one on, which value you want to do the inner join. So inner join on E reports to equal to M dot number. I want you to just combine these two together and just find out. So look at that. Now it gives me, and it gives a E dot number, E dot extension, M dot number, M dot extension, and it is just giving extension and numbers, and where employee M on E dot reports to. So whoever employee reports to that one, it will show the employee himself and as well as the manager, who is the manager of that particular one. Right? And then there comes some of the types of joins. Number 8. One of them is called left outer join. Left outer join. This is very interesting. Left outer join. What does that mean? Look at that. Select E dot number, E dot extension, M dot number. I should have copied that one, but let's see that. Extension from employee as E. So we'll just represent employee as E, and now see that left outer join employee as M. It just left outer join to M. Now, which fields I want it to just join them on E dot reports to equal to M dot number. Make sense, everyone? Left outer join. Now, what is left outer join? This is quite interesting, and I'll show you diagrammatically what does that mean. E dot left outer join. Now, first of all, let's run that and see that what happens. Do you see we are getting null over here? Left outer join says that from the left part of the left part of the join, take out all the values, even though if they do not have any relevant value in the right side. Are you guys getting that one? Left outer join means all the value from the left one, just bring up, and even if they do not have any matching value on the right side. So that's why you see that some of them you will find null over here. So this employee, for example, if you look at that, this employee extension as it does not have a manager or something. It is not managed by something, but left join means it will show all the employees over here. Are you guys getting that one? Now, a much more interesting example of left after join. Left means the left part, bring everything from the left column, and you can leave out from the right column, and you can just say that. So left outer join 2. Let's its second example. So prerequisite of a computer course. We are finding prerequisites of a computer course. Now this is quite interesting. You will see that what it will do. So now we are trying to find those prerequisites of a course of COMP, computer courses, right? Comp courses. So now let's do that. Select C dot number, C dot name, CP dot prerequisite number from course C, and then it is left outer join with course prerequisite end. Course prerequisite end, and I will call it CP. Now, which field I want to do that? I say C dot number. You see that course number should be matching to what? CP dot course number. Makes sense? It matches to that one, but this is not the case because we have the computer courses. So where C dot number, like anyone remembers, if I want to recognize any computer course starting with comp, what should I use? Anyone remembers the wildcard? I will use the wildcard over here. I will use, where is that? This comp and which one? Comp percent. Comp percent. So all those C dot number courses should be again comp and anything after that. Anyone remember this percent wildcard from last class? Anyone? Percent wildcard, what it does? Because last class I just explained that quite comprehensively. We have done certain examples as well of that code. Anyone remember that comp card? If you don't remember, you'll have to just go and look that again for the exam purpose as well. So look at that now. So it says comp 1230 database design. Its prerequisite is info 1570. Comp 1380 advanced viewer applications. It has no prerequisite. Advanced course. Applied SQL comp 1230. ID support, project management, etc., etc., etc. It is just giving all those which are basically falling on that one. Make sense? So that's quite interesting one. Wonderful. Now let's come back over here and let's write this query in a different way. Select number, name from course C, where number like comp 1%. Look at that. Comp 1%. Which was just the first one. Look at that. So comp 1, database design integration and user integration. And again, here we are just mentioning and just printing that out. So it brings out that one. So here it will just display that one. And here it will just represent what are comp 1. So you can find comp 2, by the way, just like that. This is wildcard is so important. Remember, comp 2. Number name from course C, where the number like comp 2. Make sense, everyone? Wonderful. Now let's move forward. Now, one more example. Let's see some more examples of selecting the course. Select course number. And why is there space? Select course number, prerequisite number from course prerequisite and CP, where course number like, I have missed out S in the previous one. We'll do that. Comp 1%. Let's do that. Course number. Look at that. What we have done. We are saying that select course number and prerequisite number from course prerequisite and one course prerequisite and course CP, and where custom, where course number like comp1. So wherever, just select those courses which have one, one starting with the one. But I think that it should have one more. It should. No, this is the one, right? This is the one. Okay. All right. Now, this was the left outer join. Now let's talk about right outer join, number 10. We are now finding out right outer by using right outer join, the prerequisites of comps courses, right? By using the right outer join. Right, let's do that. Select C dot number, C dot name, CP dot prerequisite number from course prerequisite and CP, and now right outer join, now not left outer join, and make it with course C. Now, which values I want to do that? C dot number, not name, number is equal to CP dot course number. Now here comes, now here is a condition where C dot number, like, again, the wildcard, comp, sorry, not single quotation, comp percent, anything that has comp. So look at that, when you apply the right outer join, what will happen? Look at that, right outer join, it will just, bring up all the columns, all the fields from that, from the right side, and the right side is the course number. For example, if you look at that course number, CP, the CP is the the CP is basically the course prerequisite. So, these are all the values that have been coming up over here. And this is just mentioning over here what are comp related courses. Right. Now the next one, not last, not the least. 11, full outer join. And what we are doing over here, find employees and the schools they work at. Let's do the step 1. By using no join. Let's do that by using no join. Select code name from school. We have a database called school, data table called school, ordered by code. We have not used any join. Look at that. It says course, like the code and the name. Code BUS business and hospitality, CA career and academic, etc. From school. School is one of the table. I'll just see that. Let's end that. So school has code, name, and French name. Both of them. Now there is no join over here, and it is just bringing up what? Code name from school, order by code. So it is just bringing this one. So if I just run that again, it is just bringing code and name from school with no join. Now, if I add a join, step 2, inner join. Let's use inner join here. And we'll use the implicit type of thing, right? So let's do that. Select school dot code. So remember school dot name, employee dot number, employee dot extension, and from school. Now see here, inner join employee. So you have to go and inner join with the employee. And where school dot code equal to employee dot school code, right? Order by code. Now this is the join. This is the join using that one, right? There was no join over there. Now here's we have a join. Let's see that. Now it is because it is bringing now from the two tables over here. So now it is bringing school.code, school.name from school table, and employee.number, employee.extension from employee. You see that this is the classical example of inner join, and it is telling us that which employee is basically, this is employee number, employee extension, whose employee are basically on a typical school. So in the business code is school, business and hospitality, this employee number, this is working, and these are working. So they are all the employees that are coming up by using the inner join, and they are just coming up over there. So this was the inner join. Now you will see inner join, and I'll show you both running together. Then you will understand that concept. Step 3. If I do left outer join, that would be quite interesting. Look at that. When we are doing left outer join, you will see the difference between these two. So if I just copy this one, because I'll have to change this a little. Select school.code, school.name, employee.number, same from school. Now, rather than inner join, I'll say what left outer join. Left outer join, and again, join with employee on school code is equal to employee.school code, that is mentioned, ordered by school code. I just keep everything separate, same. Now let's run both of them. And I show you something. First of all, I run that inner join and then left outer join. Look at that. For the inner join, I'm just getting what? I'm exactly trying to extract everything same. Business hospitality and this, wonderful. Business hospitality, this matches. Now here comes CAA, which has no number and extension. Like, maybe it does not have any employee or extension of that employee. Can I have a thumbs up from everyone? Do you guys understand? Left outer join means anything from the left should be represented, even if it does not have a relationship over here. Sunil has given a thumbs up. Wonderful, Sunil. So this is left outer join, and it is basically from the left side, take out all the fields. So CA is coming up over here. But over here, if you see that CA is not there, because there we are inner join. Only those which match the condition should be there. And over here, if you look at that, health and safety is coming up over here, and health of life science, liberal studies, and media and design, which do not have any values in the employee. So no employee works for them, for example. So still it is just representing over here. Wonderful. So you guys understand that one? This is basically what? Only Sunil, I just saw Sunil's thumbs up. Now step number 4. If we do right outer join of this same. Step 4. Right outer join. If you do the right outer join of that exactly the same. Now I'll again copy and paste the same. I have already copied, I think. Yes, this is here. And now rather than inner join, I'll just come here and I'll say right outer join. Right outer join. And I keep the same, right? So now let's run this one. Now see here. Sunil, do you understand that one? Now you see that it's showing null and null on this side because I'm doing right outer join. So it says that even if the school code, like for example, and on this side, because we have got that, right outer join to school, from school, if there is no existence, even if you have to just bring from right everything. And understand that it will just bring up the right. And even though this employee number and this extension, so this employee extension is not related to any school, for example, but it just shows null and null, and it just shows null because it represents that it is the right outer join. Can I have a thumbs up again from you, Sunil? I think it was only you that did that. Okay, Yash, thank you. I can see your Hitesh, wonderful. Now last step 5 and full outer join. Right, so let's keep that same and let's do that full outer join. Right, full outer join. Let's see what full outer join will do. Now, can anyone explain full outer join for me? Because now you have got the output over here. I would like to know that, does anyone know what is full outer join? Yes, anyone? If you understood that right and left join properly, you will understand this full outer join as well. This is the best example that would make it as
I think
understand.
it gives all the output like from the right as well, left as well.
Wonderful, Begin. So Begin, as its name suggests, full outer join from right, from left, everywhere, wherever there is a value, you have to just bring that, even if there is null on the either side. Wonderful, Begin. That's wonderful. You're right. Right. So this is basically, these are some of the, the examples, and we have just done that one. So what you can do for that, particularly if I want to, for today's little work, have you guys started working on your assignment 1? By the way, you will be working already, and on the starting on that one. So let me share one thing with you. Okay, yes. So everyone has started um, working on that one. I was talking about assignment 1. Oh, sorry, assignment 2. Assignment 1 is very simple. Assignment 2, and there is still a time left in this assignment 2. I would be expecting you guys to just maybe have some of them. So now what I'll do is that I would like you to just have gone through. Let me see one of the article online. This is an interesting one. I've not heard from anyone from just that they've started working on assignment 2. That is quite interesting. Yeah, this article is good. If you want to just I would like you guys to just read out this article, right? And I'm just mentioning that. Here is the article link. And again, I'll share this code file with you. Just give me a second. I'll share this code file with you. Yes, I'll save that. And I'll save that in our folder here. Codes. And this will be week 4. No part 1. Week 4 will have just one part. Week 4. Let's say part 1, just to synchronize the name. Part 1, save that. So this is an article. If I just show you. So it has again given all those examples, right join, left join. Look at that and try to come up with some of the examples by using either this one or Northwind. Northwind, the assignment you are working on, there will be some Northwind. So what you have to do is that you have to, after going through this one, write at least 10 joining queries, 10 join queries, and submit. So again, just like as we have done in the previous weeks, this time you will be just writing 10 queries. And I have just mentioned that a lot of time that always submit this one, because this will be important and helpful for you with when we will have in the end, if you are mentioning or if you are missing something, you will definitely find that. So here week 2 practice and week 3 was just submitted by 5 people. You can see that over here. I'm not concerned, no problem, because you will, as I said, this will be a very good important thing in the end. If you don't submit that, no worries. I'm just opening that is ungraded, but its time is today till 5 p.m. Again, our class time, and go and find the question in code file for this lecture, and which is week 4 part1.sql. It should be there on our course shell. It should be there. I'll just, I'll just upload that for you. Week 4, and I'm just adding the file, upload the file. It's there, week 4 part 1. This file is here, and you can always use that one to work with that one, right? So question is there, and it is mentioned at the end. Learning, you can have this, read that personally, that article, and you can just, do that. Any questions thus far from anyone? And if you do not have any question, write down no question, because that would typically be a sort of attendance over here.